This is a continuation of solving by factoring. We'll look at some application problems and then a couple of special cases as well. So this is a rectangular problem. Width of a rectangle, 6 feet more than twice its length. If the area is 56 square feet, find the dimensions of the rectangle. So maybe a picture would help. It doesn't have to be a perfect picture, but here's a picture of a rectangle. It says one side is 6 feet more than twice the other. So maybe I'll let the length be x. I mean, you could let it be L. I don't like writing L's because L's start to look like ones after a while. So there's its length. It says the width is 6 feet more than twice its length. So there's twice its length. There's 6 feet more than twice its length. So there's twice its length. There's 6 feet more than twice its length. It tells me the area is 56 square feet. Now, if you remember how to find the area of a rectangle is length times width. So the area is going to be length times width. Well, they told us the area was 56. So 56 is x times 2x plus 6. That's the hard part. Hard part is setting up the equation. The rest of it shouldn't be too bad. So let's distribute that x so that I get 56 equals 2x squared plus 6x. And now I'm going to move the 56 over to the other side. So I get 0 equals 2x squared plus 6x minus 56. Now, here's something you can do. In the previous video, I was talking about don't divide both sides by x, don't divide both sides by x plus 4. In this case, I can divide both sides by 2 because 2 is a constant. No variables involved in 2. So you notice everything on the right-hand side is divisible by 2. So let's make life a little bit easier. Divide everything through by 2. So I end up with 0 equals x squared plus 3x minus 28. And now that's pretty easily factorable. I'm looking for two factors that multiply to be negative 28 and add up to be 3. So maybe 7 and 4. Which one should be negative? The 4 should be negative. So 7 times negative 4 is negative 28. 7 plus negative 4 is positive 3, right? The positive is bigger than the negative. So I get x plus 7, x minus 4. Now here's how we want to be careful. If x plus 7 is equal to 0, x is negative 7, right? What number plus 7 gives me 0? It's negative 7. Over here, what number minus 4 equals 0? It's 4. So it looks like I got two answers. I got x equals 4 and I got x equals negative 7. If this were a regular old problem, then we'd be done. But this is a problem talking about a rectangle. So if I say x is negative 7, I'm saying one of the sides of my rectangle has a negative length, which in the context of this specific problem does not make sense. It doesn't make sense for the side of my rectangle to have a negative length. So I'm going to say that's not going to work. What about 4? Well, if x is 4, then what are the dimensions of my rectangle? One side's 4. The other one is 2 times 4 plus 6, right? So 2x plus 6. 2 times 4 is 8. 8 plus 6 is 14. And then you can multiply 14 by 4 and see that you really do get 56. Last thing is, what is the question asking? It says find the dimensions of the rectangle. So the dimensions of the rectangle are 14 feet by 4 feet. So we should always go back and make sure that we've answered the question. Sometimes the question might simply say, find the length of the rectangle. Well, then we'd be done. Length of the rectangle would be 4. Sometimes it'll ask us to actually find the dimensions, and so those are our dimensions. So when you get to the end of this problem, once we've set it up, solved for the variable, go back and make sure the answer makes sense in context of the problem. And this one, the negative value does not make sense in context of the problem. All right, here's another one. Window washer accidentally drops a bucket from a landing 144 feet in the air. The height of the bucket is after t seconds is given by negative 16 t squared plus 144. That's a fairly standard equation. That 16 in front of the t squared comes from the acceleration due to gravity. So gravity on Earth is the same everywhere. So that's where that negative 16t squared comes from, and we're measuring it in feet. When will the bucket hit the ground? In other words, the poor person that's standing under the bucket, how long do they have to move before they get hit with a bucket and a lot of water? Well, the ground is at height 0, right? The window washer is up here, 144 feet in the air. The bucket drops, it goes down, hits the ground. Where's the ground? The ground is at height 0. So I can replace this h with a 0. And I get the equation 0 equals negative 16t squared plus 144. Well, is there a common factor between the 144 and the 16? I mean, the first thought might be, can I take 144 and divide it by 16? The answer is yes, I can. So actually, let's make this easier. Let's factor out a negative 16. So negative 16t squared divided by negative 16 is just t squared. Turns out 144 divided by negative 16 is negative 9. When I factor this completely, I get negative 16 times t minus 3 times t plus 3. Well, the negative 16 doesn't give me anything, right? Negative 16 equals 0 makes no sense, so I'm going to get rid of that. So it looks like the answers are t equals 3 and t equals negative 3. Only one of these two makes sense. When will the bucket hit the ground? Here. 3 seconds after the window washer drops the bucket. The other half of it turns out t equals negative 3 is 3 seconds ago. So why do I come up with a second solution? Look at that little graph that I graphed you. There's another half to the graph that appears on this side over here, and the negative 3 is where it intersects back there. In the context of our problem, it doesn't make any sense at all. So the only answer, when will the bucket hit the ground? 3 seconds after the window washer drops it. All right, this says a frame surrounding a picture is 2 inches wide. Picture inside the frame is 7 inches longer than it is wide. So this is going to be a little bit of a mess to draw. So we should draw it in a couple little steps. Overall area of the picture and the frame is 198 square inches. Find the dimensions of the picture inside the frame. So there's a picture, then there's a frame. Let's look at the picture first. It says the frame surrounding a picture is 2 inches wide. The picture, all right, this is what I need. The picture inside the frame, 7 inches longer than it is wide. So if this is how wide it is, it's 7 inches longer than it is wide. Now, I'm going to take a frame and I'm going to put that frame around the picture. Around here, 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 and there. And the frame is 2 inches wide. So it's 2 inches here, 2 inches there, 2 inches there, and 2 inches there. All right, so the little purple piece here is the width. But now the whole picture frame is a width with 2 more inches at the top and 2 more inches on the bottom. So 2 plus 2 is 4, meaning that whole side is W plus 4. Now look across the top. The purple piece is 7 inches. That's the inside of the picture. But now there's 2 inches to the right and 2 inches to the left. So 7 plus 2 plus 2 is 11. Those are the outside dimensions of my picture and the frame. So it says the overall area of the picture and the frame is 198. So 198 is equal to length plus width, so W plus 11 times W plus 4. You'll see problems similar to this. Let's say you were putting a walkway around a pool. So the purple piece in the middle is the pool, and then there's the walkway around the pool. How much is the area of both of them combined? So maybe you're putting a fence around both the walkway and the pool to keep the neighbor kids out in the middle of the night so nobody gets hurt. So you're going to have a rectangle on the inside, then a walkway around. Okay, a walkway around a garden is another type of problem you'll see with this. All right, so let's see if we can solve this problem. See if we can solve it here. If I need more space, I'll pull up another window. So FOIL out the right-hand side, so you get w squared. Plus 4 plus 11 is plus 15w. 11 times 4 is 44. But now let me subtract the 198 from both sides. So I get 0 equals w squared plus 15w. And then 44 minus 198 gives me minus 154. All right, so two factors of 154 that have different signs. I don't know. What's 154 divisible by? Let's try an even number. It's not divisible by 6. It's not divisible by 8. It's not divisible by 4, but it is divisible by 2. 77 and 2. Well, if it's divisible by 77, then it's also divisible by 11. So let's take 154 and divide it by 11, and I get 14. 11 and 14 don't seem to work out, but look, 14 is even. So divide 14 by 2, multiply 11 by 2. And those are the numbers that I need. I need the 22 to be positive and the 7 to be negative. So that's sort of my thought process. I could list out all the factors of 154, but sometimes it's interesting to see how the teacher solves a problem because you could do it the same way. So if 11 and 14 don't work, then cut one in half, double the other. All right, I have what I need. So w plus 22, w minus 7. Check and see if it works. I got a w squared. Minus 7 plus 22 gives me plus 15. And then 22 times 7, 22 times negative 7 gives me negative 154. So here I get w equals negative 22. Here I get w equals 7. Well, my picture frame's not negative 22 inches along the side, so 7 makes sense. The question says find the dimensions of the picture inside the frame. Well, the picture inside the frame is the purple one. So inside the frame, if w is 7, 7 plus 7 is 14. And that's 7. So the picture inside the frame is 14 inches by 7 inches. And then if somebody asked you for outside the frame, then you would end up with what? 14 plus 2 plus 2 is 18. 7 plus 2 plus 2 is 11. And my final check would be to multiply 18 times 11 and see that I do get 198. All right, let's break this into the third video for the last couple examples.